All right, so problem number 3, which is false. A, the empty set is a subset of any set. B, the empty set is a subset of itself. The empty set is a subset of the set of natural numbers. Or the set that contains the empty set only is a subset of the empty set. Now, just to clarify, when we say the empty set, it's I like to think about it like this. It's just it's a container, and it's just these kind of curly braces. But you could, in the future, maybe you could put something in it. You could put a 1 in here, you could put a 2 in here, a 7, a 3. But you can also, have the empty set inside of another set. So now we have, two empty sets inside of an empty set. There's nothing in any of them. But, there could be one day, we could come in, we could put a 3 in here, and now we have, a set with a 2 and a 3 in it. The idea is that, these are kind of like containers, and they're not exactly like variables, but you might, think of them as variables, because, when we say A is equal 5, it could be anything. A could be, if we don't define what A is or what's inside of A is really just kind of a placeholder container that could represent anything inside of it. And so that's kind of how I think of the empty set. An empty set can have an empty set inside of it. It could have multiple empty sets inside of it. Or it could just be the empty set by itself and nothing inside of it at all. Looking at A, the empty set is a subset of any set. Well, we know that it's true that the empty set is a subset of every set. And there are proofs for that. In fact, on homework number 1, we are asked to prove that the empty set is a subset of every set. So for now, I'm going to say, just take it at face value that this is true. But if you want to see the proof, watch the video on the proof that proves that the empty set is a subset of every set. So this can't be false because it's obviously true. So this is not the answer here. But then the same thing when we look at C, the empty set is a subset of the set of natural numbers. Well, this is a set, and we said that the empty set is a subset of every set, so clearly this is not the right answer. And then the only thing left here is that the empty set is a subset of itself. Well, we have to look at our definition of what a subset is. And a subset is basically saying that, here we could say that A is equal to this and B is equal to this as well. And both of these are the empty set. For B to be a subset of A, every single element inside of B has to be in A. Well, if we look at it, we don't even have to check anything because there's nothing to check. The set is empty. So by definition, yeah, every element that is in B is in A because we can't say that there's an element in B that is not in A. You can't point to one element inside of B that is not also inside of A because there is no element in either of them. So therefore, by definition, this is true. The empty set is a subset of itself. So that finally, that is process of elimination. We can say that D is the correct answer, but the set that contains the empty set only is a subset of the empty set. So at that point, we're saying that, this is a subset of this. And technically, this would be considered an element inside of B that is not inside of A. So therefore, the correct answer, the better way to go about this is probably process of elimination, but this is definitely the correct answer. And we can also kind of prove this to ourselves like by contradiction. Let's say that B, for example, is a subset of A. Let's just assume that that is true. And if we look at A, we do know for a fact that A is a subset of B. Number one, because the empty set is a subset of every set. But also we know that there's nothing in A that is not in B. So we do know for a fact that A is a subset of B, but we're assuming that B is a subset of A, which would mean that A and B have to be equal by definition. So we can see that that's not the case. A is not equal to B. This is an absurdity, therefore it's not true.